All right, get ready to go beneath the surface today as we answer your request to dive deep into the fascinating world of the heart. You've sent over some great material on cardiac anatomy, and I'm really curious to unpack all this together.
It's a topic that never gets old for me. The heart's more than just a vital organ. It's a testament to the power of natural selection, optimizing every feature for peak performance.
Okay, so before we get into the nitty-gritty, could you give us the 2-minute overview of what the circulatory system is and what it does?
Absolutely. Think of it as a complex transportation network. With the heart as its central hub, we're talking about roughly 5 liters of blood, continuously circulating through this intricate system of blood vessels. Every cell in your body, from your head to your toes, relies on the system for oxygen, nutrients, and waste removal.
It's incredible to think about all that going on inside us every second of every day. So where exactly is this mighty organ located? And what are our first impressions when we get up close and personal with it?
Picture this. Your heart is nestled snugly between your lungs, slightly left of center. It's about the size of your fist, and actually leaves a subtle imprint on your left lung, something called the cardiac notch. That always fascinates me, how the heart essentially carves out its own space.
It's like it's saying, hey, lung, scoot over, I've got important work to do. And speaking of its location, that central position is no accident, right? It plays a crucial role in CPR.
Absolutely. That central location makes it accessible for chest compressions, which can be life-saving in an emergency. But the heart's not just free-floating in there. It's got its own protective layer called the pericardium.
Okay, let's talk about the pericardium. What's the deal with this protective layer, and what is it like?
The pericardium is a double-layered fibrous sac that's surprisingly tough. Think of it as the heart's own personal bodyguard, shielding it from external shocks and impacts.
So it's there to prevent the heart from getting bruised or damaged.
Exactly. But it's more than just a physical barrier. Between those two layers, you've got this slippery, seroless fluid. This fluid acts like a lubricant, allowing the heart to beat smoothly, minimizing friction with each contraction.
That makes sense.
Yeah.
You definitely wouldn't want your heart rubbing up against your rib cage with every beat. But our research mentions that things can go wrong with this fluid.
Right. There's a rare but serious condition called cardiac tamponade, where the fluid balance in the pericardium is disrupted. It can compress the heart, restricting its ability to pump effectively. This highlights just how important that fluid balance is for proper heart function.
That's a good reminder that even though things are often running smoothly behind the scenes, it's essential to have an appreciation for how delicate that balance can be. So we've talked about the heart's location and this protective sac. But what about its internal structure? What's going on beneath the surface?
Okay, so we've made it past the pericardium, that tough bodyguard protecting the heart. What happens when we go deeper? Our sources mentioned 4 chambers. Is this where we get into the whole pumping action of the heart? You got it. The heart is essentially a 4-chamber pump, and each chamber has its own specialized role to play. Think of them like rooms in a well-organized house, each designed for a specific purpose. You've got the atria. Those are the 2 smaller chambers at the top of the heart.
The atria, those are the receiving chambers, right? Like the heart's welcome back committee.
Exactly. Blood that's low in oxygen and high in carbon dioxide enters the right atrium from the body, while oxygen-rich blood from the lungs enters the left atrium. So the atria are all about receiving blood. They then deliver it to the ventricles.
Okay, so what are the ventricles up to while all this receiving is going on?
The ventricles are the real powerhouses of the heart, the 2 larger chambers at the bottom. They're responsible for pumping the blood out to the rest of the body. The right ventricle pumps blood to the lungs to pick up oxygen, and the left ventricle, the strongest chamber, pumps that freshly oxygenated blood to the rest of the body.
It's amazing how the heart seamlessly manages these 2 different circuits, one to the lungs and one to the rest of the body.
That's the beauty of the heart's design, and it's all kept flowing in the right direction by those one-way valves we talked about earlier.
Right, the balancers of the heart, making sure everything goes the right way. So we've got 4 chambers, 2 atria, and 2 ventricles all working together. But what about the walls of these chambers? What are they made of? I'm guessing it's more than just your average muscle.
You are correct. The heart's walls are made primarily of a very special type of muscle called the myocardium. And this is where it gets really interesting. It's not just a simple squeeze.
Yeah. Our research mentioned something about a spiral structure.
That's right. The muscle fibers in the myocardium are arranged in this incredibly intricate spiral pattern, almost like a work of art. And there's a reason for this elegant design.
Let me guess. That's all about efficiency.
Exactly. This spiral pattern allows the heart to generate a powerful twisting motion as it contracts, squeezing blood out with maximum efficiency. It's like a finely tuned machine optimizing every ounce of energy for maximum output.
And I read somewhere that researchers compared a healthy heart structure to a Gothic cathedral. That seems like a strange comparison.
It does seem strange, but when you think about the arches and buttresses of a Gothic cathedral, how they distribute weight and provide strength, it starts to make sense. The spiral arrangement of muscle fibers in a healthy heart serves a similar purpose, providing strength and resilience for a lifetime of beating.
So a healthy heart, with its intricate spiral structure, is like a Gothic cathedral, strong and enduring. What did they compare a failing heart to?
Unfortunately, a failing heart where the muscle fibers are weakened and less organized is more like a Roman ruin, once majestic but now crumbling and inefficient. And that visual really highlights the importance of maintaining a healthy heart.
That's a powerful image. You've definitely given me something to think about. Okay, so we've explored the chambers and this incredible muscle, the myocardium. But what happens when the blood leaves the heart? How does it get where it needs to go? We've talked about the heart's chambers and that incredible myocardium, but the journey doesn't stop there. Our sources mention arteries, veins, even a lymphatic system. It seems like a whole network dedicated to transporting blood throughout the body.
You're exactly right. Think of arteries and veins as the highways and byways of your circulatory system. Arteries are the vessels that carry blood away from the heart. They're built for pressure with thicker, more elastic walls to handle that surge of blood with each heartbeat.
So when I feel my pulse, I'm actually feeling the surge of blood through an artery.
Precisely. And most of the time when we talk about arteries, we're talking about oxygen-rich blood being delivered to the body's tissues. But there's an important exception, the pulmonary artery.
Right, the pulmonary artery is the one that carries deoxygenated blood from the heart to the lungs to pick up a fresh supply of oxygen.
Exactly. It's all about context. Now, once the blood has delivered its oxygen and picked up carbon dioxide, it needs to return to the heart. And that's where veins come in. Veins carry blood back to the heart. And they're a bit different from arteries. They have thinner walls and rely on a system of valves to keep the blood flowing in the right direction.
Fascinating. So it's a two-way street with arteries and veins working together to keep that blood flowing throughout the body. But what about these two sets of veins mentioned in my research?
Ah, yes. You've got your deep veins, which typically run alongside arteries and share their names. These are the workhorses of the venous system, carrying the bulk of the blood back to the heart. And then you have the superficial veins located closer to the skin.
Those are the ones we can often see, right? And the ones doctors usually go for when drawing blood.
Exactly. The superficial veins play a vital role in temperature regulation, but they also provide an alternate route for blood flow if needed.
It's amazing how our bodies have these backup systems in place. So we've got arteries, we've got veins, but our sources also mention a lymphatic system. What is that all about?
Great question. The lymphatic system is like the circulatory system's unsung hero. It's a vast network of vessels, tissues, and organs that play a crucial role in maintaining fluid balance immunity and absorbing fats from the digestive system.
Wow, that's a lot of responsibility. How does it tie into everything else we've talked about?
Well, as blood circulates through capillaries, those tiny blood vessels, some fluid leaks out into the surrounding tissues. This fluid, called lymph, is collected by the lymphatic system and eventually returned to the bloodstream.
So it's like a drainage system, making sure fluid doesn't build up in our tissues.
That's a great way to think about it. And along the way, the lymphatic system also filters this fluid, removing waste products and fighting off infections. It's a crucial part of keeping our circulatory system healthy and functioning properly.
It's incredible how all these systems are interconnected, each one playing a vital role. It really makes you appreciate the complexity of our bodies.
It truly is remarkable. And speaking of remarkable, we can't forget about the amazing transformation the circulatory system undergoes before birth.
Oh yes, the fetal circulatory system. That was one of the most fascinating things I came across in my research. It's completely different from our circulation after we're born, right?
That's right. A fetus gets its oxygen and nutrients from the mother's placenta via the umbilical cord. And since the fetus's lungs aren't functioning yet, there are a couple of bypasses in place.
Bypasses, like detours.
Exactly. One of these detours is the foramen ovale, a small opening between the two atria, which allows blood to bypass the lungs. The other is the ductus arteriosus, a vessel connecting the pulmonary artery to the aorta, also bypassing the lungs.
It's amazing how adaptable the circulatory system is changing to meet the needs of the developing fetus. And then when the baby is born and takes that first breath,
Those bypasses close up, the lungs kick into gear, and the circulatory system seamlessly transitions to its postnatal configuration. It's truly a remarkable feat of engineering.
wow, that is remarkable.
Yeah.
Before we started this deep dive, I knew the heart was vital, but I never realized just how intricate and elegant its design truly is. From the chambers and valves, to the spiral muscle fibers of the myocardium, to the network of arteries, veins, and lymphatic vessels. It's a symphony of coordinated action.
I couldn't agree more. And the best part is that we've only scratched the surface. There's so much more to discover about the heart's electrical system, its response to exercise, and its remarkable ability to adapt and repair itself.
It makes you wonder what else is going on in there that we haven't even considered.
Yeah.
Well, on that note, I think we've given our listener plenty to ponder today.
Indeed we have.
This deep dive into the heart has been fascinating. I, for one, have a newfound respect for the organ tirelessly beating away inside my chest. As always, it's been a pleasure exploring these sources with you. Until next time.
The pleasure was all mine.
And to you, our listener, thanks for joining us on this deep dive into the wonders of the human heart. Keep those questions coming, and we'll keep exploring.